Okay, so in order to solve by factoring, okay, so here's what I do. I look at my quadratic. If b is equal to 0, I'm going to go ahead and solve by square rooting because that's the easiest thing to do when b is 0. But there's plenty of times when b is not 0. So I need some other tool, okay? So one of these other tools is to solve by factoring. Now the downside to this is that not every quadratic can be factored. So that's why later on this week we'll add more tools to our tool belt to solve those types of quadratics that you can't solve by square rooting or by factoring. Yep. You better hurry. Oh my goodness gracious. Okay, so you can only solve by factoring when your quadratic can be factored. So for example, if I gave you this here quadratic and I said go ahead and solve this one, y equals, oh I don't know, how about x squared plus 5x minus 1, okay? If you tried to factor this one, a is 1, so that's good. I just need factors of -1 that have to be positive 5. Do they exist? No. So this cannot be solved by factoring. I will be showing you later on this week what tools we can use on this. So this one is not factorable. So I can't use it. Can't use this method. All right, let's try one that I can. So let's start off with one that's not so bad. How about, you can use t's here, yeah. If I had x squared, let me do, let's do plus 3x minus 4. Now, if you recall from last week, what we're really trying to find, right, if we think about the graph of this, remember how I told you that anytime that you graph a quadratic, it comes out to look like a U shape? And the two answers that you're actually finding are where it crosses the x-axis? Do you kind of remember that last week? Well, if you don't, that's okay. So that's every time you have a quadratic and you graph it, they come out to be U-shapes. What we are finding when we are solving a quadratic is where it hits the x-axis. Okay, so we're going to find those two locations. That's why I keep telling you that there's always going to be two answers, right? Because it's going to hit twice unless I have a weird case where the U doesn't touch the x-axis at all. Those are the square roots of the negatives. But anyway, we're going to get more into the graphs next week. So what I can do with this, remember what's going on with y at these two spots. What's the value of y? 0. So remember our first step last week was to replace y with 0 if we have one. So that's the same thing. I'm going to replace the y with the 0 if I have a y at all. Sometimes they give it to you, they just start you off like this. Yeah. And now what I want to do is I want to factor this just like you did in the last chapter. A is 1, so I want factors of -4 that add to be positive 3. You can make the t's if you need to, but hopefully you just have them in your head.
4 and then 1.
Yes, a positive 4 and then -1. Now, here's where it takes a minute to wrap your mind around this, but once you get it, it'll make sense. Okay, so I'm going to leave this for 1 minute. Isn't it true that anything times 0 is 0?
Yes.
Right? So if I had two numbers, let's say I had a times b. If either a or b was 0, then this whole thing would be true, right?
Yeah.
So what I need to do is I need to ask myself, well, what number makes this thing turn into a 0? -4. If I plug in a -4, doesn't that chunk turn into 0? And then I actually don't even care what this is because anything times 0 is 0. Yeah.
Why? Why does making on a -4 change?
What's -4 plus 4? 0, right? So anything, so whatever this is times 0, it's going to be 0. So, Grace, what number would I plug in over here that would make this chunk turn into a 0? Yes, positive 1 minus 1 would turn that into a 0. Okay, guys, listen. Shh. So there's a very easy way to find it. Guys, are you listening? All you have to do, I want this thing to equal 0. Yes, it's very easy to look at it and just say, well, negative 4 would make that happen. It's not always going to be that easy to just look at it and say. So what you can always do is take the factor and set it equal to 0 and then just solve. So minus 4 from both sides. One of my answers is negative 4.
Okay. Now that makes sense.
Then I take this one, same thing. This thing could also equal 0, and then the whole thing would equal, right? If that was 0, it doesn't matter what this is. 0 times this whole thing would equal 0 still. So I take this, x minus 1, and equal it to 0. I can add 1 to both sides. My other answer is a positive 1. So just like last week and at the beginning of class, whenever we solved the quadratic, we got 2 answers. I'm still going to get 2 answers. It's just that these aren't going to be positive, negative of the same number. They could be, but usually they're totally different. So when I go to write the answer, since there's more than one of them, remember we like to use these squiggly brackets, and you're just listing them.
Is there any specific way to write those?
No, it's just a list. So if I said to you, name for me all your brothers and sisters, you can give them to me in any order, right? It's just a listing.
I meant the bracket. Is there any specific way to write that?
Oh, no, I mean, just do your best. Give me a squiggle and a squiggle. You cannot make them smooth, because that's an ordered pair. So this is telling me if I were to graph this quadratic back here, it's telling me it crosses the x-axis at negative 4 and a positive 1.
Okay.
That's what those numbers are. Okay? So, let's try another one.
Wait, so could you just technically just flip the signs around?
Yeah. As long as there's no number in front here, because sometimes there will be, and then it gets a little bit weirder. Now, you can check these answers. You can take negative 4 and 1, plug it back into the original, right? And it should equal 0. Let's take 1. 1 squared is 1, plus 3 minus 4. Doesn't that get you 0? 1 plus 3 minus 4? Yep. Take negative 4. Plug it in. Negative 4 squared is 16, minus 12 minus 4. Is 16 minus 12 minus 4? 0? Yes. You can always check your answers. Your 2 answers, if you plug them back in, should always get you back to 0. Okay, let's try.